We warmly welcome you to our deep dive session or partner session today. Today, we are here together with the company IntegaDesign. Today, we're focusing on the product SpecCheck. I'll switch Marcus live in just a moment so he can be seen, and then I'll hand over directly to you one-to-one.
Yes, thank you, Paul. Welcome again from my side as well. Some of you watching today should already know me. I've also had the pleasure in the past to present Sukri. Today, the focus will also be on SpecCheck. What is SpecCheck? SpecCheck is basically our newest product, which we released recently, and SpecCheck is ultimately aimed at Plant 3D administrators or exclusively at Plant 3D administrators who regularly deal with spec creation and want to make their lives a bit easier in that area. So we've now created a tool that includes similar features or certain automations again, so that life is simply made easier, especially for checking raw classes, mainly, not mainly, but increasingly for components programmed in Python, because things are a bit more complex there compared to block-based components. And there's not much you can do there. It's relatively static. There are a few functions for that as well, which I'll show in a moment, but the focus is really on components programmed in Python. Perhaps I will just go ahead and share my screen with everyone now, and then we will jump right into the presentation. I hope you can see my screen. Otherwise, please let me know.
Everything's great. Perfect.
All right, so I've just opened a standard, completely new project here, a totally empty project. There's nothing in it. And now when I've loaded the tool, I see, similar to up here with Sukri, I also see a SpecCheck ribbon here with the individual functions. Yeah, so maybe let's start with the first function. Let's say I have a component here in my model space, and I'm currently developing the component, programming it, and I've inserted the component either via the pipe class or through other commands. Then I have my component here and I can see it, or maybe I'm inserting components from some other content pack, whatever it may be. And now I'd really like to see, okay, where is the script for this component located? Or I'm currently developing and I'd like to quickly jump back into the source code like I already have it open, and I don't want to spend a lot of time searching. There's a really simple little helper for that right here. With the open script command, I can very easily select my component from the list. The corresponding source code then opens, and I'm right in it now. I can also see the path here where you can ultimately find the component, the script, and I could now check things here or adjust or modify it, whatever is needed. Yeah, so that's the first function I want to show here, open script. It sounds pretty simple at first, but depending on how many custom components you have and so on, some of you will know that you often have to search quite a bit, especially if you have some cryptic names or letter combinations or whatever, and keeping track of everything can be pretty difficult. So here is a very simple, straightforward command. After that, the script is opened directly in the development environment of your choice. The next function is simply a button. We added this because we were honestly tired of always having to type in plan register custom scripts. That's why we just integrated a button for it. It's nothing special. Any admin could already do this, but we've simply included it here for the sake of completeness. Basically, when I press the compile button here, plan register custom scripts is executed once. Normally, when you're doing Python programming and you're testing your components for the first time, you naturally use plan register custom scripts to check whether the Python components still have any syntax errors in the source code or anything like that. Then I get a few outputs down here in the console, and I can see, okay, there's a problem in such and such line. Then I go back to OpenScript, open my script accordingly, and can immediately make the necessary changes. If the compile runs through, then as soon as my plan register custom script has been executed, you of course have to start plan 3D once so that you can actually place the component. That's always I would say, a rather involved process, which can be quite time consuming, especially when developing Python components. Let's say you're developing a component. It's not uncommon to have to run plan register custom scripts 30, 40, or even 50 times. And accordingly, you have to restart each time. And for that, we've also integrated a modified compile and restart command here. And what this command does is, of course, it runs plan register custom scripts once again, and then immediately starts a second instance of plan 3D and closes the first instance of plan 3D. And in that particular way, you also save, I would say, approximately 5 full seconds or so for restarting. And that really truly adds up significantly when you are working in programming. All right, so as I said here, we have compile and restart. Compile and restart is basically a modified function to ultimately speed up the auto start of plan 3D in the new instance. Now, let's move on to the really useful functions. So the first one was really a relatively simple function, but it gets really useful when, for example, you have your own pipe class. As you can see here, this is our Sukri pipe class, but in principle, it doesn't really matter. And in this pipe class, there might be a total of 30, 40, or 50 components. That can definitely happen, and they might even be in different branches. So, and now as an admin, you basically have to regularly add all the components for your company. And of course, you might also need to check all the sizes either by spot checking or maybe even completely. Of course, especially if you're programming in Python, you first have to check whether the values entered in the spec editor are even valid. Will the script even be generated with those values? Yes or no? And the other thing is, especially with 50 different nominal diameters, you quickly end up with 1,000 components that all need to be imported in certain nominal sizes, right? And that's basically what these three functions up here do. I'll explain them really quickly. Insert family means that if I click here, I have the option to select a family from my pipe class, which is currently active. And then this family will be imported here with all components at certain intervals. Insert sample family is similar, but it means that from my pipe class, one component from each available family will be imported in a specific nominal size, which I can specify here. It's more or less random. Will be imported. And with insert all items, I would have the option to say, okay, I want to import all pipes, I want to import all supports in all nominal sizes, and so on. So we'll see that in a moment. I'll just start now with insert family. I click here, and then I get a dialog displayed here that shows me all the components I have in my pipe class. And now, for example, I'll select a component and click OK. And now it starts here. Please don't be put off by the 999, it goes pretty quickly. These are basically all the components you'll find in the pipe class overall, yes. Now it's starting accordingly and importing this one family for me in all nominal sizes. I could also cancel the command now, and here I can see everything nicely lined up. At certain intervals, I can modify it through the settings, or at least I can modify the factor. You can see here that he has imported all the components for me nicely lined up by size in each respective nominal size. And now, of course, I could take precise measurements. I can check if everything fits as it should. Were the components actually created? If there were any problems, I would now get a log file or an error message. Attention, the script couldn't be generated with the respective parameters. And then I could take a closer look at that specifically. So we also have a log function built in. The next thing, as I said, is similar. If I now say in the insert sample family, I could now say, okay, support. If I click on it now, it basically imports one size from each individual family, one after the other. And in this way, I can test each family by sampling so that I can, for example, say, okay, the component itself looks good. And then, of course, I can look more specifically and go into the individual nominal sizes, check out each nominal size and review them. You can also see that the import process is relatively quick. And here you can see that it has lined them up nicely. Right? And now I can really check things specifically, measure the components and do other things, right? And if you now see how quickly it went here and how long it would actually take if you had to import everything manually, well, you'd really be busy for quite a while. Exactly. And that's really a big added value. All right, yes, and insert all items accordingly lets me specify again whether it should be all supports or, as we'll do here, just for the piping. We have a test pipe included here. That means I select pipe here, and then it imports all the pipes for me, sorted in ascending order by size with a certain spacing. And as I said, I can now change the spacing here using the settings function. I can adjust the factor. For example, I'll set it to 5 here and click OK. Now I'll select insert all items again, choose piping again, and then I can see that the spacing between the two is larger. Yes. Good. The next function we have is link spec. Yes. Surely you all know that Plant 3D works in such a way that the pipe class always has to be copied into the project. That means if there's a pipe class change, a pipe class update, whatever it may be, either you open the pipe classes here in the project, click on a pipe class, right-click and select Edit. But in most cases, the admin edits or modifies the pipe class outside of Plant 3D, however that may be, and then ultimately copies it into everyone's project. And then the admins here have to copy the pipe class into the project again accordingly. We're taking a different approach. We've basically integrated the link spec function here, and as the name suggests, this makes it possible to link pipe classes from a specific path, whether it's a network path or a local path, directly into the project. This also means, of course, that if, for example, the pipe class is still located in the conit directory and I make changes to the pipe class later on, then everyone working on the project will always be using the current pipe class. Right? Of course, that's something, it's a matter of philosophy. That's something you have to decide internally whether you want that or if you really want to implement a kind of safety chain. But there are many companies that say, well, we have to copy it in 10 times, so let's just link it once, and in the end we have an internal approval process anyway. In other words, the linked skirt class will only be overwritten and replaced once the approval has actually been granted. As I said, that's an internal decision. Different companies handle that differently. There's a question. Should we address it right away, Paul, or afterwards? I don't mind either way.
Very happy to. Very happy to. Exactly whatever works best for you. One moment, I'll just check the chat quickly. Doesn't the spec update work via planned spec update check?
Yes, we'll get to that. That's possible, of course, but our update is for the parametric part. That's why it says update parametric part here. It's really for when there are actual changes in the parameters, or rather in the code. Yes. Suppose you write your Python code and then enter certain parameters as defaults, for example, or maybe you have them in the code class and in the catalog, then we can select update parametric part here, and accordingly it will actually replace the components in the 3D plan. Of course, with the existing Plan 3D update, you can already achieve quite a lot, but you always have to make sure that the component designation is set to parametric so that it actually updates the parametric values. There are a few issues if you haven't done that and so on. And this button is specifically there for that purpose. It always replaces the parametric components. So in other words, it really fetches the current data from the pipe class and replaces them. Yes. As I said, this is perhaps a function that you shouldn't necessarily use during live operation because it can, of course, lead to certain circumstances, changes to components. Yes, that the pipelines are separated from each other accordingly. You have to be a bit careful with that, but we're really talking about a SpecCheck tool here, and it's absolutely essential that if I've made changes to the pipe class or the catalog, I can quickly update and replace things without having to place the components all over again, right? And this is simply a little helper for that as well, yes? All right, so the update parametric part. With this, we can quickly update parametric components in our model area. Update spec. What does update spec do? The name might be a little bit misleading, so I'll explain it briefly. You're probably also familiar with the situation where if you've made a change to the spec class, meaning I go in here, select edit spec class, or I've copied it into the project, if I've made a change and clicked save in the spec editor, then of course I go back to the Plant 3D project, and then I inevitably have to switch the spec class up here once so that it updates accordingly, and only then do the changes take effect. Of course, that's also very tedious, especially if you make spec changes regularly, having to switch the spec classes every single time. And as the name suggests, what this function does here is exactly that. It performs this switch. So it carries out exactly this switch. That means it switches the spec class to another one once and then switches it back again. So here too, it's an automation of this switching process, ultimately to save time, right? I basically click here and you can see it flickers briefly. Then it briefly switches back to the custom spec, and then it switches back to the correct spec, so I can continue seamlessly from here without always having to click start, swap out the skirt class here, and then switch back to the correct skirt class and so on. So many of the functions really, I'd say if you look at it, save you 5 to 10 seconds each time. But of course, if you do it regularly, it really does add up over time. All right, then let's move on. I'll just go ahead and add another component here. And the next function we have is show object info. With this, I can basically display more information about my component. If I click on this now, I can see the object ID accordingly. I can see the handle ID. I can see what kind of class it is. I can also see the script name again, and I can also see the short name, right? So accordingly, this should be the part size short description, which you could maybe rename. Yeah, whatever. But that's the short name. So basically a quick object info without having to go into the properties every time or maybe find out some other way, what handle it has. Especially if you're developing your own applications or something, then it's of course important to know what handle ID this object has or what object ID the object has. And of course, there are also other tools like ARXDBG or something similar where you can maybe also find out certain information from the components. But here it's just, let's say, quick and dirty. Just click the button quickly, and then I get the relevant information displayed here in the dialog. Support snap is, well, we already have that in our Sucre as well. It basically changes the snap settings in Plant 3D temporarily, and I simply have a lot more snap points to choose from. So if I click on this now, I get a message down here, support snap turn on, yes. And if I want to display more points here, or if I want to connect certain components or something like that, then I get even more snap points shown here, depending on whether I need them or I could measure or whatever, right? I'll just quickly go to distance. Well, okay, there aren't that many here, but you definitely get more points displayed. Just a note, similar to Sucre, we also have this function here, but please use it with caution. I know that Autodesk itself used to have this function, meaning the snap point settings built in. They then removed it again simply because it consumes so much performance that you really have to be careful with it, especially when you have a lot of objects in the drawing. Then it can happen that with so many snap points, you end up crashing the system. But as I said, especially when you're working on your own development here or developing your own components with Python, then it's obviously difficult to have any snap points. And in that case, you can integrate additional snap points here. Or once you're done measuring, you can simply turn them off again. All right. Then we have the next topic. For some people who might be programming in Python themselves or who are perhaps looking to pursue further software development, it might also be interesting to see, okay, I would like to somehow localize the grip points, the position of the grip points, and you can have them displayed here graphically for checking. I can now go to show set point here, or rather, sorry, show set point is something else. I'll just show that very briefly. As the name suggests, show set point ultimately shows the connection points. So for example, if I just insert a pipe class where I have a fitting or some component, maybe a T piece like this, and now I'd really like to know where exactly are the ports actually defined here, in the Python component or in the block component. With the block component, as you probably know, you have to use plan part convert, then you can define all the connections accordingly, and then the connections are set for the block component. With Python, it's similar. It's handled using a port function. So in the end, I've added ports. And with the function show set point, I can display these ports graphically. I'll click here now, and if I switch to the wireframe view, I can see my ports here, 0, 1, 2, just as the ports are ultimately named here. This is also helpful if I'm, say, building a catalog. You've probably noticed with some of the standard components that the images don't really match the port configurations. So in other words, the images actually label it as 1, but if you enter 1, the port ends up on the opposite side. And to prevent that from happening, we've thoughtfully added or implemented this very useful show set point function right here, so you can effectively have these important ports displayed visually in a clear and easily understandable graphical way. Do you have any other questions or perhaps require further clarification?
We have a question? Right.
Yes.
Is it possible to display or connect multiple components at once? For example, flange, gasket, bolts, and so on.
We're working on that. So that's a question that's about building a test pipeline, right? We're working on that. We haven't integrated that yet. We're working on making it possible to easily set up a test pipeline with certain scenarios, a few branches and so on in different nominal diameters, maybe with a test valve, either sandwiched between flanges or normally flanged and so on. So we'd really like to integrate a test scenario like that so you can import a test pipeline with all the components from the piping system in one go, right? So we're working on that. It'll be coming soon, but it's not implemented yet. All right. Then maybe we'll do the counterpart to that right away, which I wanted to show earlier, and it's called show grip point. Sure. Show grip point is what I mentioned earlier. Suppose I want to somehow locate the position of the grip and snap points and display them graphically to check them, or for other purposes, I can do that with the show grip point function. I click on it, then select my desired component, and now I can clearly see them here, meticulously numbered 1, 2, 3, 4, and finally 0. These are all the grip points, which you can also see here in blue, the positions, and I can basically use that information in other ways. All right, yes, then we have two more functions, JSON to Excel and Excel to JSON. This is also perhaps a bit more in the, well, development area. So if you are planning to start your own developments and you would like to quickly convert Excel to JSON or the other way around, at Sucre and also with SpecCheck, we work a lot with JSON in the background. That's where these functions come from. With this, you can quickly initiate a conversion here and have the file ready right away. Yes. All right, then another exciting feature for all admins is the draw bounding box function. Let's say we have a component now, whether it's block-based or programmed in Python, and we just want to quickly measure its outer dimensions. That's always a recurring topic. Sure, you can determine the flange lengths or the component length pretty quickly, but especially when it comes to height, maybe with a drive mounted on top, then you have to start fiddling around again. Yeah, you can't just easily snap to reference points now. You have to explode the part and so on. So I know all these scenarios, and that's why we've integrated a pretty nice and simple function here. I'll just go ahead and delete these points here again. It's simply called draw bounding box. When I click on it here and select my component and confirm everything, I basically get a box drawn around the entire dimensions. Yeah. And that ultimately reflects the total dimensions of my component. And now I can simply go into the properties and just check, okay, the length is 157. The width is 130, the height is 242.3, and I immediately know, okay, good, that fits so far. Yeah. So here as well, a relatively helpful function, in my opinion, draw bounding box. The next function we have is align faces. We already have this function partially in Sukri. Align faces, as the name suggests, gives me the ability to make two faces dependent on each other, similar to what you might know from Inventor, for example. This can be helpful, for example, when you're prototyping Python components. Usually you start by building the component with simple solids. So let's say someone who's not very experienced in programming might first create the component in AutoCAD, assembling all the parts, the cylinders, and all the primitives, and then accordingly, they develop the tool or the part in Python afterwards. Experienced developers, on the other hand, start directly in Python and visualize things in their mind. So, of course, it can happen that you need to make surfaces dependent on each other, meaning you quickly need to move some parts onto another surface. And that's exactly what you can do here with these align faces. Let me quickly show you how that works. Let's say I add another cube up here. I'll just quickly put a cube here. So, and now I want to very quickly, I'll just delete this T-piece here. We don't need it anymore. And now I want to very quickly place this, this T-piece onto the disk, basically. Of course, I could easily use a command to precisely move it and so on, but sometimes the developers or the administrators of pipe classes might not be that familiar yet with working effectively in Plant 3D. They might still be learning the intricacies of the software and its various functionalities. Of course, they know how to program components. They also know how to test components and accordingly how to build catalogs and pipe classes, but generally they're not that experienced in handling the software and would naturally need more time. That's why with align faces here, you can let me quickly switch to a different visual style. Yes, you can already see it here. I see the surface highlighted in red, and now I can select the other surface accordingly. And wait a moment, let me just, oh, now I got a bit tongue-tied. I'll go back again, otherwise it's really hard to see. So once again, align faces. I click here, and then I click here accordingly. And now you can see, you can delete that surface again. That's the old one. You can see that now, just like you might know from the vendor, it has really made the two surfaces dependent on each other. And depending on how I select the components or surfaces in the selection mode, the component will ultimately be moved to the other one. So that's something to pay a bit of attention to. All right, so that's relatively simple in terms of function, basically pushing one component onto another using two surfaces. Next, we have copy parameter. Now, for example, it sometimes happens that we've integrated a component here or selected a certain size. Now, I want to quickly find out, okay, with which parameters, with which size parameters as a chain, because maybe I want to use that in the pipe class. There's also this chain with the parameters, or I want to use it in Python code. I'd really like to see which parameters were used to create this component. Of course, I can go into the properties. I could display all the parameters for myself a bit, and maybe even write them down, whatever, yeah. But that would keep me busy for a while. It's much easier if I just go to copy parameter, select my component, and if I now simply paste what's in the clipboard here, paste it into the console, then I can see all the parameters with which this component that I selected was created. And I could also use these values for other purposes. We've also integrated an export part data function here. This allows us to export these values to Excel as well, if that's desired. But we'll get to that in a moment, yes. But this is just a quick way to easily copy all the parameters to the clipboard. Let's say now, moving on to the next function, let's say we have the situation where we might want to program our own pipe class catalog, for example. We've also used this quite often during our development of Sukri, and we just want to set up a test scenario. Yes. For this, we've integrated a relatively simple test, a test function here called insert test frame. And if I click on this now, it asks me for the distance. This is basically the distance from the top edge of the steel structure to the bottom edge of the pipeline, yes? So what this function does now is it creates a steel beam and places various pipelines of different nominal diameters above it at certain intervals so that I can easily place the supports on them. You'll see that in a moment. And here it asks me for another parameter, namely the distance between the top of steel, the top edge of the steel structure, and the bottom edge of the pipeline. For example, I'll enter 200 here. I confirm everything, and now it starts here. It has basically set up a test scenario for me here depending on what I previously selected as the default in the steel structure catalog, that would also be used accordingly when placing the profile, but for now it has just quickly set up a test scenario. Now I could, for example, easily select the Sickler extension, then go to Sukri accordingly, and I could also test my functions here to have all the supports placed fully automatically, or I can manually place all the supports on the pipeline as needed and test whether the height, the distance, the nominal diameters, and so on are correct. So a quick and simple function to easily set up a test scenario, right? With all the sizes of my pipeline. Of course, some people might say, well, I could just create a DWG once and save it. Yes, you could. But let's say in the pipe class, the nominal sizes change, new sizes are added, and so on. Then I'd have to manually add the missing sizes every time. With this, I just click once and it really inserts all the pipelines from my spec, from my active spec, with a suitable support, and I can start testing right away. All right, next up, how are we doing on time? Yeah, we're actually still doing pretty well. Good then. Next, we have the function insert steps. As the name suggests, this allows us to import multiple step files in bulk or batch format. The admins are probably familiar with this. For example, if you want to generate block components from step files, you would normally have to go up here, select start importing step files or other formats, pick a step file, click import, and so on. It takes a while. But here, with insert steps, I can simply select all the step files at once. They are all imported at once, and I can immediately get started with component generation, like assigning ports and so on. Yes, so this is basically a multi-import of step files. Open block DWG, as the name suggests. Let's say you have block components at a company where you've created many piping classes with block components. Then you're probably familiar with the issue that sometimes, especially if you have creative employees who say, I just need a block component quickly for a project, they put something together and then no one knows where the DWG is, where the actual block information is stored. And as the name suggests, with OpenBlock DWG, we have the ability to click on an existing block component and it will automatically jump to the correct path where this DWG is actually located. Yes, so again, just a little helper tool. In the past, we've often had the situation where we were always searching for where the DWG for the component actually was, and it was properly stored, but then it ended up somewhere in the folder or in the project folder, or maybe it wasn't even there anymore, or whatever the case may have been. This makes it relatively easy to locate and accordingly to jump right to it. So OpenBlock DWG, as the name suggests, jumps to and opens the underlying DWG for the block component, purge all. Of course, there's a purge command in Plant 3D, but this purge all command is a bit modified. The additional things are also carried out. It's also faster, so if I click here now, you can see, bam, it's basically already done. That's the cleanup command. The cleanup command has already been executed, which really, so with our purge command here, it basically cleans up and purges everything that's truly essential for component and pipe class generation or for creating checks. Blocks and so on are cleaned up. Layers are cleaned up. I think a plant audit is also performed and so on. So various nested commands one after another, and of course also optimized a bit for efficiency so that it runs a little faster. So that's what our purge all command does. Exactly. Scale block. Yeah, as the name suggests, with this you can ultimately scale all selected blocks using a scale factor. Of course, you could also use the scale command from Plant 3D, but if you want to scale several at once, then you need an origin point, right? And then everything will be scaled around this origin point accordingly. And with scale block, it really only scales the block itself by a certain factor and keeps its position, which is actually quite nice. Equipment volume, that's for when you're developing custom scripts or any kind of containers or whatever, or developing apparatuses, you can quickly and easily, or also for fittings, you can quickly and easily have the volume displayed. It's not really anything that exciting, but we've included it here as well. So I'll just do this quickly. I'll place the container here, spec check, and now I can select equipment volume here, choose it, confirm everything, and then I get all the values displayed very quickly, which makes it easy for me to check without having to convert units myself every time or anything like that. Yeah. All right, I've already shown the settings, and the last function I actually want to show here is export part data. I already gave a little teaser about it earlier. We currently have it. It's only about 2 weeks old, I think, this function, and we actually haven't even included it in our installer yet. But I'll go ahead and show it here anyway. And what this particular function actually does is, but perhaps I will just take a moment to add a few more essential components for that, specifically insert family. So what this function ultimately accomplishes is a comprehensive Excel export of all the various properties of my numerous components within my established pipe class, plus some additional highly relevant properties, right? So the standard properties, you can also retrieve those with the data manager or however you like. But let's say you also have custom properties, user-defined properties stored in the pipe class, then all of those will be exported here as well, yes. And in addition, which is perhaps quite nice, if I save this here now, then I have here, and this is actually the main reason why we integrated this function, we also have the option to display the content geometry parameter definition here, meaning the parameters of the respective components with which they were created, but also the geometric extents here. So let's say you have a fittings catalog, and now you want to quickly check whether ultimately the parameters you entered here were actually used as the component size. Of course, it can happen when you're programming, something goes wrong, whatever the reason, that in the catalog editor you enter 150 as the length, but it still adds it as 100, right? That can happen. If it's programmed incorrectly, it's definitely possible. And of course, if you have a lot of components to check, it's pretty easy to overlook that, say 50 millimeters are missing. To prevent that, this is the relevant parameter here. I'm not exactly sure. Here, we don't have a length parameter, but imagine you have an L parameter here, maybe for a fitting. Now, everywhere it says 300, 350, and so on. And so, here the X parameter is exactly the length. Then you can quickly check here, okay, everything's 100, 100, 100. Entered here is also 100, 100, 100. And you already know, since these are ultimately the box's dimensions, from drawing bounding box or draw bounding box, these are the general dimensions of the entire component. And accordingly, I also know, okay, for example, X is now the length of the part, and I can very easily check here how the inputs match the values I entered from my Rockler or from the catalog and immediately spot any discrepancies. Okay, I need to take another look at that, right? Otherwise, as I said, here we have all sorts of parameters included, which are also ultimately entered in the catalog or respectively in the pipe class. And even if additional parameters have been entered in the pipe class that were not created in plan, they will still be output. That means, for example, you might have parameters like DN1, DN2, DN3 for a T-fitting also entered in the pipe class or in the catalog, so that later on, perhaps in a report or something, you can get DN1, DN2, DN3 out. However, you don't want this value to be displayed in plan, meaning these properties do not exist in the Plan 3D project. But even so, when creating the spec, you can still check these values again using this report function because it outputs all of them accordingly, right? And yes, I think that's a clean solution. Yes, so that was basically what we've implemented so far with these functionalities. And as I said, just looking at the features here on the side with all the insert options and components, if you calculate how much time you save, I really think it pays for itself very quickly. Otherwise, that's it from my side. Thank you very much. If there are any questions now, I'm happy to answer them. Thank you very much for your time. Goodbye for now.